Couple of notes. Firstly, this is really under the heading of logs. Logs is where we're really going to dig into it. But as you know, equations with indices and equations with logs are the same equations, just written differently. Different point of view. Secondly, I'm really focused on the inequality part of this, right? You guys have been working with the equations a fair bit today and last year, at the end of last year. But when you move into inequalities, even though it seems like a fairly trivial difference between solving an equation and solving its sort of equivalent inequality, whatever. When you're working with indices and logs and transferring between them, you've got to be very careful. Okay. So let's start like this. We'll start with a simple thing that we know. Like say for instance, if I said x, sorry, that's not what I wanted. Trivially simple example like this. Okay. Now I know that you know what the answer is and you can just read it off. But I want to start with a simple enough example so you don't get weirded out by the numbers. If I were to convert this into a log equation instead of an indicial equation, how would I write it? I'm going to start with x equals log base 2 of 8. Good. Okay, so I'm growing at rate 2. How long will it take me to get to 8? And the answer is 3. So far so good. When you've got an equality, right, it's very easy to convert into a log equation. By the way, I started with x equals, but you could just as easily have said this. Now the reason why I point this out is because even though, because it's an equation, you can put it on the left-hand side, you can put it on the right-hand side, doesn't matter. But if I were to change this into an inequality, right? You can't play so fast and loose anymore because the left and right are not the same anymore. So you can't just simply say, oh, just put one wherever and then you just go for it, okay? Now, again, because this is a simple example, I think you can see what the answer to this is going to be. Like you can read off the number without doing it with logs, okay? But if we are going to do it with logs, which side, assuming the inequality stays in the same direction, which side does the x belong on? Okay, so if I take these two parts here, right, the x is going to stay on the same side. Okay, now just watch for that though. That's not like some golden rule that's always true. It's true because in this case, what I want is this. Now, let's illustrate this, okay? So it's worth picking up another color to draw yourself a set of axes. What does 2 to the x look like? Okay, I actually need a bit more space here. 2 to the x is just your standard exponential curve, and it's doubling and doubling and doubling and doubling, and it's doing something like that. Okay? Now, when I pose this first line, I'm saying, if this is 2 to the x, I'm looking at where it's higher than 8. Higher than 8. Okay? So if that's 1, then, I don't know, 8's somewhere up here. Okay? So where is this graph higher than 8? And the answer is, well, if I bring this across, there's the point where it intersects. Really should be a hollow circle, shouldn't it? Hollow circle, there. Okay, and I'm interested in the part that's above. That's this part here. Okay, so the corresponding x values that mark the solution to this are going to be x is greater than 3. Right? That makes sense. So that's fairly intuitive. This positive direction maps to this positive direction. So far, so good. Is that right? Okay, so far things stay put. But let's try another example. Okay, if I said this, do I want this? Yeah, greater than. Yeah. Well, let's put a boundary just for the sake of it. Okay. We use equations as our lens to understand inequalities because an equation, right? An equation, it will be the boundary point for the corresponding inequality. Does that make sense? Like if you just take away all the inequalities, you just change it to equals, when you solve that, you'll find the boundary where you turn one way or the other. Okay? So when you have a look at this, a half x, if we wanted to find the boundary, you'd say that equals 2, right? Now, you can tell me what the answer is, but how would you work it? How would you demonstrate how you get the answer? Yeah,
you log to the base of half.
Okay, alright. I could go straight to logs, but there's a simpler way, isn't there? Before we get there, even though that's fine. Yeah.
2
Okay, so if I can avoid logs, like if I can keep things in the language they already are, then I'll do that. If it wasn't, like, if they weren't nice neat numbers, like if it was something like a half to the power of x equals 7, then I've got no choice. Logs is where I have to go because it's not going to be nice and neat, right? But this time I can. I'm just going to compare coefficients, right? And the solution to this is?
-1.
-1, good. Okay, now, this is a bit harder because you're familiar with like how normal exponentials work, but this guy, if you were to graph this, what does it look like? Okay, and there's two different ways of thinking about it. Number one, again thinking about that growth rate idea, right? If this is your growth rate, what's happening to your object slash population slash whatever is changing? It's decreasing, it's halving every time period, right? Another way of seeing that is it's this, right? So this guy flipped horizontally. That's what happens when you put a minus sign on the x, okay? So now what does this look like? You really need to draw this. It's going in the opposite direction. It is, as we would say in the HSC course, exponentially decaying. Okay? As it gets smaller, it keeps getting smaller, but its rate of getting smaller gets smaller. It slows down. Okay? So this is what it looks like. Where is this solution? This solution is over here. There's x equals -1. And as we expected, the reason why it's over there is because it maps up to here. There's 2. So there's our solution. Now let's return back to the original question. We wanted, when is this graph, when is it above or equal to 2? Where is that?
When it's less than or equal to.
It's this part up here, isn't it? This is the part of the graph I'm interested in. Here are the corresponding y values. And so you can see now the corresponding x values are going not to the right, but to the left. Okay? So if I had done the same trick, just thinking like blindly algebraically, oh, when you take logs of both, when you convert it into a log equation, right? You just leave the x on the same side. Well, you would write this. You'd go x is greater than or equal to log base half of 2, right? But that's wrong. That's not true. I'm not x is greater than, I'm x is less than.
Because
Okay.
he divided by a negative log thing.
Right, okay, so because when you transition from here to here, it's not obvious because we're so used to thinking in terms of, oh, you just change it, it doesn't matter which side's which, okay? When you did this, we skipped a step, okay? Now, to try and make this most obvious to you, there's a few different ways we could do this, okay? Here's the way I'm going to suggest. Make it really, really obvious, okay? When I look at this, okay, I'm going to forget that I know that it's -1, okay? I look at this and I can see I want to go to the left, right? Because I want to go upwards. So what is this value in log terms? Well, my base is going to be like whatever this growth rate is, which is a half, right? Yep. So it's going to be log base a half. And I want it to be like I'm growing to such a rate that I'm 2. Now you notice that's backwards in time, right? Because this thing is shrinking, right? Okay. So now I know that the real solution to this actually is, let's come over here now, x is less than or equal to whatever this value is, okay? Now, all this time I've been using easy numbers so you can just see it. But if I give you disastrous messy numbers that don't give you nice integer solutions, okay, you will be forced to resort to actually solving it algebraically. So how do you work with the arithmetic here? How are you going to work out what this and this is? What rules do we know that can help us work with this?
You can convert the base.
There's some different choices. Okay, I could convert the base. But if I can just work with it in its present base, it might be giving me an easier solution, right? Can anyone see how I can work with this thing while leaving the base as a half? What have I got over here? Yeah, Doris?
Could you make the 2 to the power of negative?
Good. Okay. Now, if I'm putting a -1 there, right, you can't just throw -1s around.
I mean,
you've got to. This is the same, right? Now I haven't changed this, right? So this is really log base a half of that, which is a half. And the whole thing is to the power of -1. But I know, I can just put that there, right? You see that? My power has come out to the coefficient. Log base of half over half.
-1.
That's -1. Okay? So, be very, very careful when you're doing these inequalities, okay? Your best strategy is just draw a picture and then you'll know conclusively which direction you have to go in and what your inequality will end up with. Alright? Until you get more used to it.